Good morning, everyone. Thank you for joining. We are back with the next session, meetup number 3 for with user group Punjab, which will be on focused on AWS CloudFormation, a very renowned service in the entire cloud market when we talk about things like infrastructure as a code, automation, and DevOps. CloudFormation is a prominent tool in that entire list. And today in this session, we will be looking a deep dive around what exactly is CloudFormation, or why do you need CloudFormation and different features and functionality of it. So let's hold the seat and let's move forward with the next slide. So today's agenda, what I'll have for you guys is first, why we should use CloudFormation, what is exactly CloudFormation, how it works, couple of concepts around it, couple of more access control, and backed by different demos. So we understand by the end of the session that why do you need CloudFormation features functionality, followed by some more hands-on to ensure that after this demo, you have some more knowledge about it. Before we start with our session, let me give a quick introduction about myself. My name is Sanchit. I work as a lead architect 25, an AWS APN ambassador, as well as an active communist, a speaker, public speaker. You can reach out to me via different medium, LinkedIn, GitHub, Twitter. I'm almost active in all the social media platforms. If you need any of my help specific to your career focus or how to adapt AWS, feel free to reach out to me. I'll try my best to get back to you as soon as possible. Now, let's jump and understand why exactly we need CloudFormation, right? Before we learn and understand what exactly is CloudFormation, it's very important that let's start with why, right? That will make our journey very easy. So first, support for different resources, right? When you talk about CloudFormation, it's about support for different resources, any resources which is provided by AWS, whether we talk about S3, whether we talk about EC2, or we talk about Lambda. CloudFormation supports automation for all those different kinds of resources, right? There are provisioning which is not just limited to AWS resources. If you have resources which can be accessed via some Python code and all, that kind of support also you can do with CloudFormation. So it supports different resources on AWS or something which can be interact with some SDK form outside AWS. Second, why we need to use it is because it's easy to use, right? As we'll start going through the demo, you'll understand that it's like a couple of quick lines in YAML and JSON format, which makes it very simple to use, right? There are different other mechanisms also, which I'll talk about in upcoming slides, where you can see, even if you don't know YAML, if you don't know JSON, you let's say are from software engineering perspective, still you can use different forms of CloudFormation, which can help you to achieve infrastructure as a code. Third, as I was talking about, very flexible and declarative syntax, like the syntax are very much modularized, right? How do we focus in any programming language, more of like object-oriented concept? Similar kind of a setup here is that the modules, I mean, the entire things have been very modularized, very structured, different, that help you to reuse, and you get those kinds of same benefits what you generally see in object-oriented programming. Customization through parameters. So when we always talk about things like modularization or having more of reusability, one of the important thing is how we can customize it. So you can reuse time and time across different environments, different regions, different accounts of AWS. So those all kinds of stuff you can do. And again, need not to worry how much it is declarative, flexible, or customization. We'll understand in detail when we will be looking in the demo around it. At the last, there are functionality provided by AWS itself on the CloudFormation console, where you can drag and drop and design your CloudFormation. So let's say, even if you're not from a DevOps perspective, neither you have any experience around software engineering, but still, if you want to go ahead and write your first CloudFormation, you can easily do it with drag and drop UI, right? So neither you need to be very techy around it, or neither you have to be having very specific knowledge. If you know what you need to build, that kind of functionality also you can do with drag and drop UI. These are the different kinds of there, right? If I recap, support for different resources, easy to use, flexible and declarative, customization through parameters, and drag and drop. This 5 pointers makes us to use AWS CloudFormation, and it's very renowned service when we ever talk about AWS cloud. Now let's understand what is CloudFormation about it, right? Because we understood why it is important for us, but now let's understand what exactly is the CloudFormation, right? So If we collect all those 5 pointers and try to place it here, will be easy to understand it. So CloudFormation is a very simple way to create, manage, and provision sets of resources, right? So very simple example, which I always try to talk about when we are referring to CloudFormation. Let's say you land up in a new job, and as a part of your responsibilities, you have been asked that, okay, you have to deploy 5 EC2 instance, right? With same set of resources. Maybe let's say you have to install Google Chrome, Nginx server, and Python. These are the 3 resources you have to launch or you have to deploy in an EC2 instance, and such 5 EC2 instance you have to launch. You will easily do it for one day. If I ask you do it for the 1 week, some or other way you will even drag it to 1 week. If I ask you to do it for next entire 6 months, you will go crazy. It's like what? Every next day I have to come up, launch 5 EC2 instance, deploy around the resources around it, and that's what my job is, right? You'll start hating your job. There exactly, you will try to figure out some other optimization way of doing the things, right? Maybe some Python script, some bash script, or some other way where you run when you're launching EC2 instance, right? That, okay, when I'm launching EC2, let me run this. But if I tell you there is a mechanism where you can even automate the way you can launch EC2 instance, not only the deployment of the software. That's exact automation strategy is a CloudFormation. So CloudFormation not only help you to automate, manage, or provision or your resources, but it can also help you to automate the deployment also of the resources via bootstrapping and all, right? So in short, it is the mechanism to create, manage, provision, and even deploy your resources. So if you are looking this 4 perspective, then CloudFormation is a go-to tool, right? And in our example, we were only talking about, let's say, EC2 instance, which is one particular service. When you talk about real world IT industry, when you talk about any cloud platform, what you deploy, even a smallest application consists of 15 to 20 different resources. There are different kinds of provisioning, different types of configuration, what you have to do, which becomes very difficult. How are you going to remember all those things, right? And when you always rely on human brains, there are mistakes, there is slippage, which is bound to occur. There, CloudFormation makes and execute things in a very order and predictable way. So it's not only help you to manage, manage your resources, but help them to execute in a very order and predictable way. So if we go and read the definition now, we'll understand it. AWS CloudFormation provides a simple way to create and manage a collection of AWS resources by provisioning and updating them in an orderly and predictable way. The same is what you can see in this picture, which is at the below. If I ask you to create and manage resources manually across this, even this sets of resources, you feel like, okay, this is crazy. But if I ask you that I'll give you a simple script, you just have to go and launch that script, you'll happily do it. Doesn't matter, it's launching 10 resources, it's launching 100 resources across 15 environments. If I ask you just go and launch this CloudFormation template, you can easily take care of that, right? And the CloudFormation can ensure that all the internal wiring and all the sequential that needs to be taken care. So that is the CloudFormation. Moving towards the next, right? There are many companies. Expedia is like an online booking platform. There are many other companies you will talk about where they use in and out about CloudFormation. I mean, honestly, I've seen like in last, the CloudFormation just got launched somewhere around in 2015 reinvent. But if I talk about the adoption of CloudFormation, in last 5 to 6 years, CloudFormation is always an integral part of any solution. Things like if you're talking about any data lake platform, any machine learning platform, or any application development, CloudFormation is an integral part of it, whatever you try to build around, because everyone wants to minimize the operational overhead that comes up when you launch any platform. So Expedia is one of them, but you will see there are many other examples when it comes to the CloudFormation. Moving towards the net, how exactly the CloudFormation look like, right? We understood about what is CloudFormation, why do you need, but what exactly is a CloudFormation, right? Is it we know it's a AWS services, but is it something you have to write something and do it, or how exactly it works, right? So there are 3 core pillars, I would say, or 3 different terms in CloudFormation. First is the entire template. Second is the CloudFormation, and third is a stack. This is very basic concept, but a very important thing to remember. Template is like a script. I would say any script which is written in a JSON and a YAML format is a template, right? Like you save a JSON file, YAML file, which is in a CloudFormation, which define all your resources, is called as a template, static definition of the resources. CloudFormation, the AWS service on the console, which help you to convert template into a stack. Stack, if I define another way, is the executable or the execution of the template in a deployed format. So whatever you define, let's say, for example, in the template you define launch an SQS, launch a Lambda, and let's say launch an S3 bucket. This is what you just define static wise, or your syntax wise, you define it in a template, in a text file, in a JSON or a YAML format, which is called as a template. Now you take this template, upload in a CloudFormation service, and CloudFormation execute that template and create a stack of it. So when you have the stack successfully deployed, you will see the SQS, Lambda, and S3 are lively deployed on AWS console. And that's as a set of that resources is called a stack, right? So that's a three basic concept: template, CloudFormation, and stack, which we'll learn in detail as we move forward. Now, for example, if you go very deep into what exactly is CloudFormation is in technical perspective, is all resources required by user and application can be deployed very easily using templates. As I mentioned, you can define all the resources what you need as a part of your application in a template, which is across all the AWS resources, what you need, and CloudFormation will take care of it. The second is you can reuse it, right? As we learn in the why section, that there are different ways where you can customize it by providing different parameters. You can have more modules, more syntax around it. That makes it more reuse and replicate the infrastructure in multiple different environments. Third is to make the template reusable, use parameters, mapping, condition, so that different perspective to make it more customized, right? How if we talk about any programming language, you part input parameters. You first of all, you define the modules, right? You don't write a chunk of code. You define into different modules of it. In different modules, you just forward the different inputs around it. Similarly, in CloudFormation, there are different parameters are there, mapping, condition is there in the template to customize your stack when you create them. So here are the three important things: is what is AWS CloudFormation. Next is how exactly the CloudFormation works. So CloudFormation, if we take slide back, right, where I talk about you had template, your CloudFormation service, and then you have a stack. Similarly, this is the picture in a very granular mode, how exactly in real scenario it works, right? So starting from the left side, first you have code your infrastructure, right? So whatever you need to define, let's say you want to provision a Lambda, you want to provision an S3 bucket, and with not just provisioning the S3 bucket, what kind of configuration, the name of the Lambda, the different runtime, whether you need in Python, you need in Java, the memory, the IAM roles. That's what exact static syntax what you define of Lambda, along with the different configuration you need to give in either a YAML or a JSON format. Once you have that entire file ready, then you upload that file to S3. Now, some people will, if you would have tried in the past, some people will say, I never upload the file in S3. I directly go in AWS console and try to do that, right? But when I'll demonstrate the demo, I'll walk you through. You upload the template in S3 bucket or not, CloudFormation always launch by uploading your template to S3 bucket and refer the S3 link to deploy a stack, right? So it's an optional as you think as an end user perspective, but if we go very zoom in view in CloudFormation always picks up the template from S3 bucket. So it goes to the S3 bucket, this entire template in the same template object, S3 object form. And then when you run in the CloudFormation service on the console does a couple of things. First, it checks whether the template can be reached out. Two, it checks all the syntax defined in the template. Does it make sense or are there any syntactical error around it? Three, it draws a dependency graph, right? Now, this is like very difficult. You won't even get in any documentation, but this is how it works, right? Whenever you define a CloudFormation template, you just write the different blocks of the statement, right? You never arrange in a sequential. It's not expected that the end user has to arrange in a sequence. But when a CloudFormation executes the template, the first thing after doing all the syntax check it tried to create a dependent graph, right? For an example, what is dependence graph can be, you're launching an Lambda, you're launching an S3, you're launching an SQS. Now, it may be required that your Lambda first needs an S3 bucket. You're passing an input parameter to Lambda. So your Lambda needs an S3 bucket, right? So what it does is, first, when it's trying to launch, it will check, okay, I have 3 resources, S3, Lambda, and SQS. Second, it will check the syntax of it, all good. Third, it will check, are there any connection or dependencies are there across resources? So it will identify, oh, S3, I need to launch first because Lambda needs S3. So what it is going to do is, first, it's going to launch SQS and S3, and then it will launch Lambda at the last based on once the S3 is successfully deployed. So those kinds of dependency graph also CloudFormation service creates. And once all those mapping and has been done, then it goes and at the last, it launch a stack, which is a deployed version of your template. So this is how the entire detailing of the CloudFormation works behind the scene. Now, so far we have understood it. I think we are pretty good with understanding what the CloudFormation is and other stuff. Now let's look at deep dive. What are the different kinds of operation you can do across the 3 concepts what we have learned? Template, CloudFormation, and stack. So in case of template, parameters, resources, configuration, right? As I gave an example of that Lambda, that you define a block when you're writing a template, when you're writing a template in a JSON or an YAML format, you define a resource, you define the property or configuration of resource, and then you have a parameter mapping and those kinds of different sections to make it more reusable. Similarly is the here, you have a parameter definition, you have the resource creation, and then you have a configuration actions. So that's what different kinds of operation you can do on template. CloudFormation. It's an AWS service. So CloudFormation, what you can do, either you can create stack, you can delete stack, you can update stack, you can roll back and all other stuff also, right? So roll back, I'll explain you what exactly is an important thing after I go through this slide. It's a very crucial thing, right? And that's the wow feature, I would say, of the CloudFormation. A very simple, but a very important one. So those are the different kinds of operation, what you can do. Stack is a very important thing. Now, stack is the actual best place where you version your resources also, right? Version, I means you have a package of resources, and as you update, the resource get updated. So you can create a version of resources. You can identify the difference from version 1 to version 2 of resources. You can have different kinds of comprehensive service support, and you can just have the entire packaging of your resources, what you provision, right? So those kinds of different stuff you can do in terms of stack around it. Now, before we move to the next slide, right, it's very important that we understand the functionality of the rollback. So in case of database, we would have heard the atomicity functionality, right, in the asset property. So what is atomicity is like either it will fully get executed or it will be rolled back to level 0, right? Either you are at the destination or you'll be back to the source. Same as the concept of rollback. Let's say when you try to launch the stack template and something goes wrong, some of the resources got failed or there was some small conflict that turned out. Very simple example is you ran out of the quota. Let's say there are certain soft quotas are there, right? You ran out of the quota. In that case, what's going to happen? The resources got failed. It didn't got deployed successfully. So it's going to delete all the resources that got launched successfully by the CloudFormation. So for an example, if I give you a more concrete example around this, let's say you have Lambda, you have S3, and you have, let's say, SMS. Now, the Lambda got launched successfully. S3, when it started launching S3, CloudFormation realized that you already consume 100 buckets, which is a soft limit of S3. So you cannot launch 101. So S3 deployment got failed, but Lambda was successful. With the help of rollback functionality, it's going to even delete or destroy Lambda, and it will go and say stack failed, stack rolled back successfully. So that means none of the resources which you define in template got launched. That is a default behavior of CloudFormation. If you don't select anything, then that's a default behavior of CloudFormation. But there are ways, there are mechanisms which you can let CloudFormation know that even though if you have failed, don't roll back. Stay where exactly you are. That is more helpful when you're troubleshooting. But do always remember the best practice on a production scale is to roll back to level 0 So this way, you don't have to troubleshoot what got launched versus not. It is very easy that you just fix the error from the console. You look into the events, fix the error, and then launch from scratch rather than trying to troubleshoot and fix the error and rerun that, right? So it's always the best practice that you enable the rollback, which is by default. But in case of lower environment, you can just try around and try to troubleshoot. So that's about the rollback. Now, if you talk about the template quickly, so template we understood in very detail about that it's a JSON and YAML language. It helps you to create, view, modify your template, as well as as I talk about in the first slide, that there are functionalities which are available, which you can design, right? If you don't know, let's say JSON, YAML, how to write JSON or YAML, or if you don't know any programming language, still you can write the template with drag and drop. So drag and drop capability in the CloudFormation console is not to design real-time resources. It will help you to generate the template. So there are that will only help you to simplify the creation of the template, but still you have to deploy the template and then the stack will be deployed. It's not that you click on Lambda, that means a Lambda get provisioned there. So just watch out of that thing. And in the flow process, you just, this is like a different step to it. You first write the stack, you make a change in that, you make a view, execute it, and then create around it, right? So in case of CloudFormation, let's say, for example, first you wrote a Lambda, you view, you deploy. Now you realized that after Lambda, I also need an SQS now to hold my request. So you can update the same Lambda and you can update the same CloudFormation stack, right? Incrementally, you can make the changes in your same template and you can rewrite the stack which got deployed, right? So that's a workflow around it. That first you go from 1 to 4. And similarly, after change that, if you feel that I need to have more provisional edit, you can keep optionally adding on the same original stack and follow the same process. So that means you can overwrite or keep appending in the same template. Similarly, you can overwrite, or you can make changes as well as update the stack, right? There is one thing I'll talk about in terms of overwrite when we go to the stack section of it. This exactly is very important when it comes to the template, right? We understood it's a JSON, YAML, it's written in a file, but what exactly you write in a file, right? Okay, syntax, but what exactly in syntax? So there are the 9 main objects what you need: format version, description, metadata, parameters, mapping, conditions, transform, resources, and output. Okay, there's too many things around it. Let me tell you, the simplest of all is you need resources. Resources is a very mandatory thing. If you don't define resources, then what you're trying to launch, right? So all the 8 of them are optional. Resources is the only mandatory object what you need in terms of the template. It's a best practices, I would say, to have different mapping, metadata, and all of this stuff. I'll help you why exactly and when. But just remember that if you're pretty new and you want to just start writing your CloudFormation, then resource is the section which you need. You can skip for the first 2 steps, the remaining 8 objects, right? Now let's understand which are those 8, what exactly are these 8 objects and why you need it, right? So this is like a format of pattern to understand how exactly the things are get defined in a JSON on the YAML format. So template version is not for versioning our CloudFormation. It's not like V1, V2 kind of a thing, right? It's a fixed format which AWS is given. This is a fixed template format which we have to follow. Second is a description. Now, again, as I mentioned, you can skip the description and all, but it is very important that description is like you describe what this CloudFormation is going to do. So if I give you a CloudFormation template and I tell you, there's no description, you go and read, right? If it is a small 5-10 liners, you're going to read. But if let's say if there are like 100 line of CloudFormation template, it's like, I don't understand what exactly this is, right? Too many resources, someone is talking about Lambda, SV, SQS and all. That's a kind of a description, a note which talks about what exactly you're trying to achieve in this CloudFormation template. A simpler, I am trying to deploy a CloudFormation template which will launch AWS Lambda, AWS S3, and an SQS. That's kinds of stuff. Looking at that one line, the person can identify what you're trying to achieve. Metadata is again the metadata about different resources, like the parameters of it. If you have a parameter, what is string, what types of integer it is, right? So that's what you define. As we learned in the previous slides also, parameters are very important. This is a part of that customization. If you want to reuse your template again and again across different regions, different environments, then parameters are the go-to thing. Mapping is very important. Mapping, generally what people do, right? Even you would have heard the scenario or you would have experienced it. When you're always in the dev environment or lower environment, you use small configuration like T2 micro, T2 large, or XYZ, right? But when you go to the production, you automatically try to increase it to, let's say, M5X large, M5 4X large. How exactly you can switch automatically, right? Without making any changes when you promote your CloudFormation template. There exactly you can define a kind of a mapping or with help of mapping and configuration that, okay, if an environment is X, you launch Y sets of configuration. If an environment is Z, then you launch the A sets of configuration. I will walk you through a sample template, how exactly this can be done. But do remember, parameters, mapping, and condition is very important if you want to reuse your template or make it more dynamic so you can reuse across different environments. Transform is a pure sense of reusing a template. Let's say you already have defined an S3 template for another component and you want to reuse. So you can directly point to S3 bucket where you have this S3 template reside for S3 bucket. You can directly plug into it, right? Similarly, how we do it, import statement in any programming language. If we talk about Java, you just do an import util, right? Or in Python, you have packages defined that you can already, someone has written around it and you consume and you can just call that. Similarly, is the kind of a state of the transform. Resources, I mean, we all know about resources is the exact thing what you need to do, like Lambda, SQS and all. What you want CloudFormation to deploy or provision on behalf of you that you deploy in the resource section. Last is output, right? It is, I mean, it help you. I won't say it's a best practice or kind of stuff. It is more an helping functionality that when you have different hundreds of resources, it is understandable. It is difficult to identify, hey, which EC2 I launch? What is an instance ID of it? What is a public endpoint of it? Or what is an URL of the load balancer, which I deploy? So those kinds of things, what you can print, it's like more like a print statement that after the resource get deployed, you print their output value so I can refer and I can point to it. So this is the structure of the CloudFormation. I mean, the thought process, the meaning of the syntax remains the same. The representation changes the way you write in JSON, which is more like a curly brackets and all of the stuff. In YAML, it's more simple, like a simple language what you have. Right? So this is what we have understood in each of it. If I take you an example on the left-hand side, your metadata, I mean, description, what we understood around it. Metadata, we understood that, okay, it's talking about what parameters you're passing. Parameters, mapping, condition, as I spoke about, it's to ensure that you make it dynamic, right? Like if you see the parameters here, you're defining, okay, it can be T2 nano, it can be T2 micro. So as per the different environments, you can switch that around it. In case of resources, you define everything that, okay, how things are, like what's your resource, right? This is very simple, where you're defining EC2 instance, you're defining the property as well as you're configuring EC2 instance or deploying, let's say, HTTPD server, and you're starting an HTTPD server, right? Apache web server, you're starting around it to ensure that whenever the CloudFormation is launched, it's not only just launching an EC2 instance, but also deploying a software and have that software up and ready when you say CloudFormation is done. And at the last, you have security groups and the output which get print. So that's about the template structure. And if we go in a detail, an example of metadata, as I mentioned, metadata is more about helping you out to understand what are the different parameters are there and why and what exactly you need to provide about that parameter. Mapping, as I mentioned, that mapping, if you need, let's say, as we understood in the example, if you want to switch mappings, that will be helpful. The best example to understand mapping is, if you would have ever launched an EC2 instance, you will see the AMI ID, right? The machine image ID differs region by region. Even if you haven't done it, just open your AWS console. You will see the AMI ID, let's say, of Amazon Linux 2 in North Virginia is different versus what you can have in Oregon versus what you have in Mumbai, AP South. Now, as I mentioned, CloudFormation, you should not modify when you're trying to launch across different regions. That's a best practice that you should write generally. Then how are you going to switch the AMIs, right? Automatically. I mean, for sure, you can take the environment variables and all, but automatically, if you want to switch it, there you can define the different maps of the regions like US East 1, US West 1, EU West 1. And similarly, you can define the kinds of, okay, you need 32-bit, this is an AMI set. You need 64-bit, this is an AMI set. So based on the region AWS is launching, which is an inbuilt functionality, right? Inbuilt pseudo functionality, it automatically picks up what exactly you need, right? So this way it automatically change internally on its own without you have to take a pain to identify which AMI I need to launch at runtime. So that's why as I mentioned, parameters, mapping, condition are very important to make your CloudFormation template more generic and more reusable. Again, there are many conditions, right? Conditions in terms of different environments you're launching the CloudFormation in dev, test, or production, how you can change the sets of the stuff, right? It is also important sometimes, let's say for an example, you want to skip the deployment of a resource itself. For example, generally we have in production, we don't relaunch database again and again because it holds the actual data, right? So you want to launch everything outside database. But since we have the CloudFormation template defined and it's same across the environment, how we can make it more generic? That the same template, when it launch in dev or UAT, it goes and deploy, let's say DynamoDB or RDS, but in production, it doesn't. There you can define things like if, FN, if, and those kinds of stuff, or those kinds of intrinsic function or conditional function via which you can say, if the environment is, let's say, dev, test, or UAT, you deploy DynamoDB. If it is not, then you skip it. That kind of also intelligent switching you can do based on different environments with help of condition. Like here, exactly, it is given, right? The same thing that you first define the environments. Condition is there, create prod request. If the environment type is equal to this prod, then only it's going to take care. So those kinds of switching, intelligent switching is also you can do with help of condition. So it's not just a simple, plain, static, I would say syntax driven, but it also has some smart capabilities and internal intelligent switching on it. Transform, as I mentioned, that if you want to import an existing kind of package, the CloudFormation template, which has already been designed, you can easily import it and provide the required properties and take care of it. Now let's understand what exactly is the stack part of it. So stack, as I mentioned, right, that template, then CloudFormation, and then the executable version of the stack, what you is a collection of resources, right, that you have it, right? And in a simple language, you can say executed version or executed package, a package which holds all the resources what you define in template in an executed fashion is a stack, right? Now you can delete the entire stack. When you delete the stack, all the resources get deleted unless and until you have defined in the template while deploying it that these are the sets of resources which you skip while deploying, while you skip while deleting it, right? Things like database, things like S3 bucket, you always try to skip because there is a data which got collected over a period of time. But web server is something like a stateless kind of a thing where you delete, relaunch with the new version of the code and all. So that is around stack. Now what we'll do is we'll quickly go ahead and we'll do a demo. So what I'm going to do is for the demo purpose, I have this CloudFormation template. This CloudFormation template is like a simple template. So it has first the metadata, what we have understood, talking about and describing our parameters, right? The parameters what we need to provide. Then you're taking an parameters, which is an environment. What environment is dev, test, and prod. And then you're dynamically taking around the AMI ID. So this is the best syntax, right? We understood in the mapping that, okay, you can take it map, you can take it another thing. Why I have done in this fashion is here, I don't have to even define AMI ID. By default, it's going to take the always latest AMI ID, which is Amazon Linux latest. Amazon 2, it's going to by default take it without I have to worry about what is an AMI ID and all this. Then I'm giving a mapping that, okay, if you are in the dev environment, launch T2 Nano. If you're in the test, launch T2 Micro, and in prod, T2 Small. Here I'm defining the exact, as I mentioned initially itself, right? The resource is a very key important function or a particular section. So here I define an IAM role around it, then I'm defining IAM profile for that role. And finally, I'm launching an EC2 instance where I'm providing the IAM instance profile, the image ID, the instance type, what I need to do, right? The instance type where it's identifying based on the environment, what kind of instance instance I need to launch. And at the last, this is the configuration which I'm giving. So this will get installed. So whenever you launch, when I will be launching this CloudFormation template, it's not going to only deploy the EC2 instance, but also execute this bash script. And this bash script will install like a Apache server. It will run this PHP script. And when the entire stack is completed, and you will see directly automatically with single click, the EC2 is ready with all the required software, and you have to just go on the URL, hit, and you will see the output. At the last, you have the web security group, you have the elastic IP, and then you watch your printing around. So if I just close all this syntax definition, you will see you have defined the AWS template format version, description, metadata, parameters, mapping, resources, output, right? Most of the things I have covered up. 2 sections which I haven't written is the condition and the transform, right? So, but you will see these are the things which I ensure, and I can assure you, if you try to run this CloudFormation in any environment, whether it's in US East 1, US East 2, West 1, AP South 1, Mumbai, this CloudFormation template will work smooth without making any changes. So that's how you should always write the CloudFormation, which is well, beautifully developed. You can read it as well as you can reuse and deploy across different environments. Now, what we'll do is we'll go ahead on the AWS console. Here, you can directly go and search the CloudFormation template, or you can directly go and search for CloudFormation. So as you can see, when I start searching itself, it gave me a CloudFormation service here. And as we understood in our slide, it has clearly mentioned at the bottom, create and manage templates, right? CloudFormation is used to create and manage the templates. Now, if you haven't launched any CloudFormation, this is how you're going to look around the template, a landing page where you can click on create stack. Let's say if you have already been using CloudFormation or someone else is using CloudFormation, then you can click on stacks. Here you will see all the existing stacks if you have deployed anything. If not, you can click on this create stack. Now the CloudFormation also has the capability to import existing resources, which means if you have some DynamoDB, which was, let's say, deployed in 2015, 16, which you were not, you or your company was not using CloudFormation, you can import those existing resources, or you can redefine new ones. So it's not just CloudFormation only supports defining new resources. You can also import the existing resources. So here, as I mentioned, there are 3 ways to provide a template. There are 3 mechanisms. Template is ready. That means you're customly defining the template. You can use a sample template from this given list by AWS, or you can design a template in the designer. As I mentioned, please watch out. Designer is not to deploy the stack. Designer is used to create the template. And once the template is there, then via designer itself, you can click to deploy the CloudFormation stack, but it is purely used to design the template. We'll go here, and in the specified location of the template, there are 2 options, Amazon S3 and upload. As I mentioned, right, initially, even if I go and select CloudFormation.yaml, you will automatically see there is an S3 URL which is generated. So it's not going to use the location or the template which I upload locally. What it will do is behind the scene, as in I upload the template from my local machine to the console, AWS console will take the template and post into S3 bucket. Now in the review page, you will see it is pointing to this particular template as this S3 location, not to the one which I've locally uploaded. Ultimately it's the same copy which got uploaded, but not that location, but the S3 location. That's exactly I was explaining you when we learned the zoom in view, how CloudFormation works. It always points to the S3 URL, whether you upload or provide via S3 or you upload it locally, but still in the behind the scene, CloudFormation refers the S3 location for the template. Next, you can provide different parameters to make this template at runtime, right? That's exactly makes this CloudFormation very generic, that you can provide the parameters at the runtime rather than hard coding it in the CloudFormation. So demo CloudFormation, I'm giving a stack name. I'm choosing next. You can tag your CloudFormation. You can provide IAM role. This is the exact option which I was saying, right? By default, you can see roll back all stack resources, right? By default, it will roll back to the 0. That's a default behavior. But in case if you want, preserve successfully provisioned resources. So let's say even if it got partially failed, it is going to save the resources which got successfully deployed partially. Here you can define more other stack policy, the rollback configuration. Even you can have notification, like each step what CloudFormation is doing, you can have that notification, and you can send that notification via SNS to different other stuff like Slack, your Microsoft Teams, on your mobiles, push notifications, those kinds of stuff you can do. You can even time out. Let's say if your CloudFormation doesn't get complete, let's say in 5 minutes, that it should be, you can even time out and you can do those kinds of stuff. For demo purpose, I'm just going to keep this as is and move to the next one, which is going to be the review screen. Now, as I mentioned initially also, right, it pointed to my S3 location, not my local location, right? As we can see here. Now it's asking us to give it an approval that, okay, hey, on behalf of end user, I'm going to deploy an IAM role and attach it to EC2 instance. Can you give me your approval or acknowledgement, which I say yes. And finally, I click on the create stack. This tag will take roughly 2.5 minutes to get complete. And we'll see what exactly gets complete, right? Just one thing which is very important to understand is CloudFormation on its own doesn't cost you anything. It's a $0 service, right? What that means is currently I'm using the CloudFormation, right? So I'm launching the stack. But so AWS is not going to charge you for consuming AWS CloudFormation service. It will charge you for the resources which you deploy via CloudFormation. For example, it's only going to charge you for the resources which you define in your template file. So if I go back to my template file, it's going to charge me for this EC2 instance, right? Minimum, it's going to charge me for this EC2 instance or some of the data and other stuff. But it's not going to charge me for deploying this template in a form of a stack. So please watch out, CloudFormation service is free, but it's going to charge you for the resources which you deploy via CloudFormation, which is anyways, you deploy via CloudFormation or manually, you have to pay for the services which you launch. So let's go back and understand what we have done. Let's recap until the CloudFormation is done. So in this lab, we will deploy an Apache web server, which is simple PHP with the user data property. Now that's exactly, if I talk about, this is a user data. As you can see in the section, this is a user data. Some of the people also refer this as a bootstrapping. Bootstrapping, that means that, okay, after you launch a server, you bootstrap into, or you deploy one more script into it with help of the user data section. And again, it need not, I mean, for sure, it has to be like a bash script, but not just limited to bash. You can also write some Java codes internally or Python code in a form of a bash, you can execute it. And this is the architecture will look like. We will hit via port 80 to an EC2 instance, which has an Apache and PHP code running into it, and we'll see the output coming out of it. Now, if I hit back to the console, so this is the AWS CloudFormation console, is right? Let's quickly understand a couple of nitty-gritties in meantime. So here you will see a stack information. Stack information is nothing but all the things which we provided for the CloudFormation, right? The location of it, the stack ID, the time, and those kinds of stuff has been there here. This is the event, the sequence, logging, what we can say, right? The way it started executing it, right? You can see the CloudFormation as some role, security group. And again, this will be directly dependent on the dependency graph. If there is any sorts of dependency, what a resource A has, let's say on B, the resource B will first get deployed, then A. So it is launched based on the dependency graph. Here you will see that it's launching the different resources like security group, profile, instance. Instance is nothing but EC2 instance, IAM role, those kinds of different properties. It's what stuff. Now it started, let's say, moving towards creating an elastic IP. Once the CloudFormation stack is successfully complete, then only you will see the output. because output is more like an automaticity. If it is complete, then only output will come, otherwise it won't come. Parameters is like an input what we gave to the CloudFormation to run successfully. Stag is nothing but the synthetic code which we provided in a form of a template to AWS, right? So template is nothing but the syntax. As you can see the name, the template here is what we provide, the same template what we had locally. And chain set, as I talk about the chain set, right? If you have, let's say, deployed one resources as Lambda, now you want to deploy SQS or other resources on top of that Lambda, you can do it with help of chain set. And as we can see, the CloudFormation is deployed successfully. How did you get to know is create complete. Resources wise, if you refresh, all the resources are successfully completed. Now you will see the output coming out of it. Elastic IP, public DNS, website URL is all form of outputs. So as you can see, I have launched in AP South 1B as an availability zone, and this is my instance ID. If you want, we can copy this. So currently I'm in AP South region, Mumbai, and I'm going to the EC2 console to verify my EC2 was launched successfully, because CloudFormation saying it does. If I go on to the dashboard, okay. So as you can see, one is terminated web server. Let it come back again. So we saw generally two servers on that console. One was in terminate state, second was in running state. And once I place the instance ID, let's say I do a control F, and I paste the instance ID, and you can see it matches automatically to the second one, which is in running state. And it has the elastic instance ID, instance IP, to ensure even if you restart the server, still you can reuse it without any problem or hiccups. So this was a simple quick demo which we have run through about CloudFormation. What I'm going to do next is I'm going to delete this. So first we create, first we will bootstrap an EC2 instance to install web server and account content. Then you will create an EC2 security group and allow access on port 80. And then finally you will view the content served by the web server. So this is what the 3-step what we have done in the simple demo. Now let's move to the next and understand the advanced concepts. So far, as I mentioned in the first slide, right? AWS is very good to go when it comes to the AWS services. But let's say you have some services which is running on-prem and which can be interacted via Python SDKs. With help of custom resources, you can achieve that. So you can ask CloudFormation to execute a custom resource like Lambda, and Lambda simply, you can write the Python code in the Lambda and you can execute the Lambda by CloudFormation itself. So here is a simple example, right? At the below. So here I'm specifying in my template a custom resource. And what input I'm giving is 1, 2, 3. CloudFormation, when it comes to the custom resource, when you try to execute the custom resource, it remember that someone has given me the duty of execution of execution wise. What it's going to do is it's going to take this list, the parameter, pass it to the input. The same thing, 1, 2, 3. The Lambda, what it's going to do is Lambda will capture the input, process it, and generate the output for the corresponding bucket. This will get successfully executed. I mean, the CloudFormation will completely will finish completely if the custom resource is successful. Just in case if the custom resource fail due to any technical glitch, the CloudFormation will be stuck for like almost 1.5 to 2 hours unless and until it gets expire and CloudFormation gets rolled back. So that's about the custom resource. The next is a nested stack. Let's say you have, I mean, as I talk about modularizing the stuff, right? You can have module 1, module 2, module 3. Now, even if you want to separate those different modules, because let's say S3 is something you're going to be heavy in demand, EC2 is something heavy in demand. So you can break it down into different modules and you can directly import those modules into the parent stack. So nested stack are the stacks created as a part of the other stack. We create a nested stack with another stack by using AWS CloudFormation stack resource. Nested stack from them contains any other nested stack, resulting in hierarchy of stack in the diagram below. So hierarchy in terms of parent and child, but it helps you to kind of execute the resource in a nested stack with proper analyzing the dependency. Now we will go and understand how exactly this custom resource work and how exactly this nested stack work. So we understand this thing in detail. What I'll go ahead is I'll close this and we'll go and open the. So I've tried to make this so far I assume that you guys are pretty good, understand the things. So this one I've covered the parameters. I'll skip parameters. As I skipped condition in the last example, I'll try to explain you. Here is the condition, right? Where I'm creating the bucket or using the default bucket. That means either I'm creating a new bucket if required, or I'm using the bucket which is provided as by default. Here I'm creating a new S3 bucket. Here is my IAM role, policy, both the lambdas. So here is an important thing. If you see the difference, right? Both technically are lambda, AWS copy object and copy object lambda function. But if you see the type on 16.9 and on 60, there's a difference between AWS CloudFormation custom resource. This is the AWS got lambda function, right? So it's almost exactly similar how you write a normal lambda function and you write a lambda function for custom resource. The only way is lambda function needs to handle pre-sign, which is nothing but the authenticated URL to exchange the request and the response. Rest, everything from an infrastructure perspective remains the same. And this is the code snippet. At the last, you have the object bucket. Let's say you can take any bucket, but we have taken object bucket where you are specifying the destination S3 bucket, copy it with artifact and create destination bucket if required, or use the default destination bucket. So this is what exactly we are going to deploy now in the form of a custom resource. So as I can see that the CloudFormation is done successfully. So again, need not to say I'm on the AWS CloudFormation console. I have searched for the service and I'm here. Now I'm going to take the template, which is there in my local machine, and will execute it. Again, need not to worry if you are using it for the first time. I will share my GitHub repository link. You can follow all the stacks and you can do it. So in meantime, as I was talking about the designer UI, this is how the designer UI look like. On the left-hand side, you can see the different sets of services. Here is what you can drag and drop like this. You can pick one, you can drag here, you can provide its properties in JSON or YAML format. And then finally, you can download that image. So that helps you in documentation, as well as you can upload that image directly from here to create the stack. What I'm going to do is the same thing what I've done in the last example. Okay, so I'll select this, choose file, custom resource. Next, I give a name, custom resources, CFT. Now, important thing, before we launch the CloudFormation template, this CloudFormation template, if you see the example, what it is doing is it's copying the object, right? Copy the object from a given bucket, source bucket, to the destination bucket with prefix. So now, as we go in the CloudFormation template, you could see that it's asking for the source destination bucket, source bucket, the object name, as well as the code. Code, I mean the folder prefix. So what we'll do is we'll go to the S3 bucket. And under recently review service, you will see the S3 bucket, and or you can directly search. If it is a brand new console, you can directly use the search functionality. Now, here you can see I have 2-3 buckets, and I'm going to use the bucket which is CFT demo destination. If I click on this bucket and we open this bucket, there are no objects in it. It's just a blank S3 bucket. So what I'm going to do is I'm going to copy this bucket name, and I'm going to paste it under the destination bucket. Similarly, now we'll go back and we'll look into the source bucket. So this is my source bucket. From a prefix perspective, this is my folder, which I'll verify. Okay, this is the same name. And now I need to provide the different source file name. So I will remove this. So it's having in the source bucket under code folder, there is one CloudFormation.yaml file. I'll click on next. Again, the same thing what we have recap in the first demo. I'll skip that. I'll click on next. I'll give a permission because I'm launching a IAM role around, and I click on create stack. One thing you will realize that the time it took to launch an EC2 instance versus time it will take to deploy a Lambda, the Lambda stack will be faster. First of all, there is nothing to do with the CloudFormation, right? CloudFormation is directly dependent on the resources and the kind of property and configuration of resources what you define. CloudFormation just help you as a wrapper, right? So it doesn't mean that CloudFormation is slow and fast. It's not that the case. EC2 takes its own time to boot, to come up, load OS, deploy. So that's why it takes more time. Whereas Lambda, we know it's a serverless. As we also seen in our first meetup, that Lambda was like a serverless. You don't have to worry about OS and everything. It's a very fast, quick spin up, spin down. That's why you will see anything which you launch in Lambda is faster compared to what you have in EC2. Like it just took like half a minute and you'll see it's done, right? So it's because of the resource what you're trying to launch, nothing to do with the CloudFormation. So as we can go back and see that, okay, I had one code in the source bucket, like in this format, code, and I had a CloudFormation in it. Now we'll go in a similar fashion, the destination bucket, right? And if I refresh it, similarly, you will see in the destination bucket, there is a code folder, and in the code, you'll see the file just got moved here. So this about is the sample example, how you can do lots of other use cases when it comes to your, I've seen like people building lots of big amount of serverless applications and everything, right? All those kinds of stuff you can do, right? Get the password from database, or let's say get some credentials from some other credential stores with help of Lambda, or some secret AMIs, like some patch AMIs, you can fetch it runtime and give any EC2 instance. Those kinds of various other application you can do with help of the custom resource. Now we'll do the last quick demo, which is around the nested stack. If I go back to our slide, so this we have done is how exactly the custom resource will work. Like you will copy the function and everything. Next is a nested stack. We have learned about the different layered approach kind of a stack. So we'll go ahead and we'll deploy a quick example around it. So first, before nested stack, it is very important. Like nested stack doesn't work like an ordinary stack. Like, okay, runtime, you provide a stack, and even if it is not, it will pick up from nested. Nested stack simply means that you have 4 or 5 different CloudFormation templates. So first thing you have to ensure is that all those templates are there in any of your S3 bucket, right? So for an example, I have loaded all those under nested stack folder in one of the S3 bucket. So I've loaded all those kinds of template, because by default, as the first template you can upload locally, but the remaining child templates, by default, CloudFormation will look up to the S3 bucket in a defined format. So if I quickly open one of the CloudFormation template, let's say if I go to the nested stack folder, and if I open the main template, so things pretty much remains the same. Resources, here you will see the things change drastically, right? Here you're defining a logical resources, and there you're giving a template URL. Template URL, you're specifying the S3 location. That okay, runtime you take the bucket name. Under nested stack folder, you will see a template called as vpc.yaml. Similarly, im.yaml, ec2.yaml, and you're providing the required parameters. These parameters are from the previous output stack, right? So this way, it makes it very clean. Now, if I would have dumped all those things in one stack, this would be bare minimum of 100 lines, right? But now this is very clean, very modularized. And the best part is, let's say in another project or in another task, if I just want to launch an VPC, I can easily do it without rewriting it, right? If I would have just sourced this everything in one package, it will be very difficult for me to launch VPC. But since I've broken it down the same way, like and modularize it, it is very easy for me to do that. So now what I have done is I have already the VPs and all those things being defined here. I'll upload the first one. The first template, I'll upload it locally from my machine, or you can simply, again, as I mentioned, you can give it from the S3. The main is the orchestration, where you define the sequence in which the things needs to work. So please ensure that the main is the orchestration layer and the remaining are the child templates. So I click next. I name it nested stack demo. You can name it anything. You need to provide availability zones for, since you're going to deploy the VPC. You have to define any sorts of environment, dev, test. These are all the properties what you are defining. This is a S3 bucket which I'm defining from where my remaining templates CloudFormation is going to pick up. This is a VPC name. I click next. Here I'm giving two permissions, right? So far I was giving only one permission, that I am allowing you to go and launch IAM user on behalf of me, IAM resources. Now here you will see this is specific capability underscore auto underscore expand. So try to understand from the name itself, CloudFormation is asking you a permission. Can I launch some additional stack on behalf of you? Auto expand permission, what is that I'm expecting, right? So that means, can I launch the remaining child templates also on behalf of you? I'll say yes, and it will start running around it, right? So automatically, when the CloudFormation will start running around from the resources, you will see it has started launching the IAM stack around it, the first and after dependency. So you will see the nested label will come up here by default, and the name will be nested stack demo hyphen the IAM stack VPC stack. This template will take around a decent time because it will launch VPC and stuff. In meantime, let's recap quickly. So this is exactly, it will be like your parent stack, then VPC, IAM, and EC2, right? So let's quickly recap what we have learned from this quick demo, right, from today's session. In meantime, this has been completed. This get complete. Let's quickly jump to and understand what we have learned so far. So we understood what exactly or why do you need CloudFormation. We understood what is CloudFormation is about. The basic concept of templates, CloudFormation, and all other stuff, like how exactly zoom in view things work behind the scene. The concept, what is exactly templates, the functionality, I mean the different syntax what you have, or different functions, objects in template structure. Each going through each of those 9 objects, and again, do remember that resource is the only mandatory thing. Rest are optional, but it's a best practice that you should use mapping, parameters, and condition to reuse your template. Stack, as I talk about, this is like an executed version of your template where you can create. Then we went through a quick demo where we talk about how to launch an EC2, bootstrap EC2, Then we understood the custom resource, nested stack. And in the last, we had a quick demo about the custom resource and the layered stack. Let's wait for a few quick seconds. I think the stack should start completing now. So as you can see, the VPC stack has been done. And as soon as the VPC stack will be done, it will launch IAM. IAM is done, then it will go to the last stack, which is an EC2 instance. Again, from a understanding perspective, this is the same EC2 what we have launched in the first sample. The same stack I have plugged here. I mean, this is more from a demo perspective. I've used the same stack, so you'll see the same output of what we understood so far. If you go in the resources, you will see that it's showing that your VPC stack is completed, and currently it's launching in the IAM stack. The IAM stack is also complete. Now you'll see as I refresh it, it will launch the EC2. In a fraction of a second, it will start launching the EC2 one. And if I refresh now, this will take like last a minute and a half or two to launch the EC2. This is the same setup what we'll have, the same template, launching in EC2, launching in PHP code in it, which will give us the AMI ID and all of the stuff. The same thing what we have understood in the first demo, it's going to do that. Let's wait for a minute for this CloudFormation stack to get complete. And then we'll see the output, what we are getting as an output there. So here, as you can see, it has already started deploying the EC2 instance now. So it's not just provisioning the EC2 instance, as we learned in the previous demo, it will also install the PHP, Apache server in it, PHP in it, set up the scripts and everything in that. That's why it's going to take a bit of more time. But the important thing for us to understand is the time CloudFormation took will be roughly around, like, if you go and see, it will be like 3 to 4 minutes. But if we would be doing this thing manually at our own, like I'm asking you to launch a VPC with a proper public private subnet, I'm asking you to deploy an IAM resource, then I'm asking you to deploy a kind of an EC2 instance with Apache server and all. Bare minimum, you will take 1 hour. If you are very expert in deploying VPC, it will take you 45 minutes to half an hour. But the same thing CloudFormation is doing for you in just less than 10 minutes. And again, you can reuse it or repeat this again and again every time across this region or another region gracefully without any mistakes. So as you can see, the CloudFormation template is also done. And by default, when all those three will be done, you will see this CloudFormation template is also successful. And if we see the timing of it, it started launching at 12:10 and it got completed at 12:15. In 5 minutes, it finished up launching the VPC, EC2 instance, and IAM role. And now if I go in the output and I click on this link, you will see I start getting an EC2 instance where it is printing my EC2 instance ID, AMI ID, and the availability zone. So this was a quick demo on custom resource as well as how to do the nested stack. And as we recap what we have done so far, that's all from today's session. Thank you for joining this session, and please feel free to reach out to me LinkedIn or on GitHub or Twitter if you have any questions around it. And as I promised, I will share this presentation as well as all the CloudFormation script in the GitHub repo, what I've demonstrated in today's session. Thank you for joining this session. Hope you have a wonderful day ahead.